Today I am going to discuss about permutation. There are 4 routes between Delhi to Patna. In how many different ways can a man go from Delhi to Patna and return? If for returning any of the route is taken, the same route is taken, the same route is not taken. Any of the route is taken. If for returning any of the route is taken, then from going Delhi to Patna, there are 4 routes. Therefore, for going Delhi to Patna, there are 4 different ways. And when we use any of the route for returning, then for returning Patna to Delhi, there are also 4 different ways. Patna to Delhi, there are also 4 different ways. Now, if there are 2 operations, here for going Delhi to Patna is one operation and for returning Patna to Delhi is another operation. If 2 operations can be performed in MOS, means here is 4 different ways, and one of these MOS, the second operation can performed in NOS, means 4 different ways. Then the 2 operation succession can be performed in M into N ways, means 4 into 4, 16 ways. Therefore, if we choose any of the route from returning Patna to Delhi, then their total number of ways is 4 into 4 equals to 16 ways. Now, if the same route is taken, when we go from Delhi to Patna, we have 4 choices. For Delhi to Patna, we have 4 choices. But when we return from Patna to Delhi, the same route is taken. Means when we go to Delhi to Patna, we have 4 choices. But when I return from Patna to Delhi, we have choosing those route. We have to return choosing only that route. Therefore, from when we returning from Patna to Delhi, the same route is taken. Means there are only one choice from returning Delhi to Patna to Delhi. Only one choice. Therefore, there are 2 events. One is occur in 4 ways and another occurs in 7 ways. Therefore, choosing one of these MOS, we can choose the second event in N ways. Therefore, the total number of ways is equals to 4 into 1 equals to 4 ways. Now, if the same route is not taken, means when we are going Delhi to Patna, we have 4 choices. But when we returning from Patna to Delhi, we have only 3 choices. Because which route we are going from Delhi to Patna, we don't choose that route for returning from Delhi to Patna. Patna to Delhi. Therefore, case number 3, when we go Delhi to Patna, there are 4 choices. But when we returning from Patna to Delhi, there are only 3 choices, because in which route we are going, that route cannot be chosen for returning. 3 choices. Now these 2 events are dependent event. One is occurring in M ways, another is occurring 3 ways. Each of these M ways, this second operation is occurring N ways. Therefore, the total number of ways when we don't follow the same route is 4 into 3 equals to 12 ways. Now another example. How many numbers are there between 100 and 1000 such that at least one of their digit is 7. The number between 100 to 1000 are all 3-digit numbers. Case 1. Three-digit number with 7 at unit place. As at least one of their digit must 7. Therefore, if we take 3-digit number with 7 at unit place, then the 10 place can be 10th place can be filled by 0 to 9, means 10 ways. The 100 place can be filled by 1 to 9, means 9 ways. Because if 100 place can be filled by 0 to 9 ways, then if 0 is in 100 place, then that will be a 2-digit number. Here only we consider 3-digit number. Now the total number of ways is 10 into 9 into 1 equals to 90 ways. As we choose First event is occur in only one way, and second event occur in 10 ways, and third event occur in 9 ways. Choosing of 10 ways, each of these 10 ways we can choose the 100 place in 9 ways, and each of these 9 ways we can choose the 7 place in unit place in 1 ways. Therefore, the total number of ways is 10 into 9 into 1 equal to 90 ways. Case 1. Case 2. Case 2. 7 at 10th place. Then 100 place can be filled by 9 ways. And unit place can be filled by 10 ways. Therefore, the total number of ways is 9 into 10 into 1 equal to 9. Case 3. Seven is in 7 at 100 place. Then 10th place can be filled by 10 ways, and unit place can be filled by 10 ways. Therefore, the total number of ways equals to 10 into 10 into 1 equals to 100 ways. Now the total number of required number will be, from case 1 we get 90 ways, from case 2 we get 90 ways, and from case 3 we get 100 ways. Therefore, total number will be 100 plus 90 plus 90 equals to 280. Permutation of objects not all different. Find the number of arrangement of the letter of the word independence. if there are n objects of which P1 are alike of one kind and P2 are of alike m kind, then the total number of permutation is factorial n by, if there are n objects, one of them P1 are P1 of one alike P1 are alike of one kind and P2 are alike of another kind, then the total number of permutation is factorial n by factorial p into factorial q. Therefore, here the letter I, the given word contains 12 letters. 12 letters, of which n occurs 3 times, E occurs 4 times, and D occurs 2 times, and the rest all are different. Therefore, the number of permutation are required number of arrangement equals to factorial 12 by factorial 3 into factorial 4 into factorial 2 equals to 1663200. Now, how many of these arrangement do the words start with P? Start with P. After fixing P, extreme left position, the 11 letters, if we fixed P at extreme left position, then the number of arrangement of 11 letters will be factorial 11, in which 3 n's, 4 e's, 2 d's, there are 3 n, 4 e and 2 d's. Therefore, the total number of arrangement is factorial 11 by factorial 3 by into factorial 4 by into factorial 2. Now, all the vowels occur together. How many of these arrangement all the vowels occur together? There are 5 vowels. Four E and 1 I. Let's treat them as a single letter. 4 E and 1 I as a single letter. Then total number of letter is 12. If we take 4 E's and 1 I as a single letter, then the total number of letters will be 8. Therefore, the total number of its letter can be arranged in factorial 8 ways. And there are 3 ends and 2 D's. Therefore, factorial 3 into factorial 2 ways. Now, total number of arrangement is factorial 8 into by factorial 3 into factorial 2 equals to 3360. Now the number of arrangement of 5 vowels among each other is number of vowels can arrange among themselves is factorial 5 by factorial 4 into factorial 1 ways. Therefore, the total number of arrangement in which 5 vowels remain together is 3360 into factorial 5 by factorial 4 equals to 5 ways into 5 equals to 16800. Now, the number of arrangement in which vowels do not occur together. In which the vowels do not occur together. Total number of arrangement minus the total number of arrangement minus number of arrangement in which vowels occur together. The number of arrangement in which vowels occur together. Total number of arrangement is factorial 12 by factorial 3 into factorial 4 into factorial 2. And number of arrangement in which vowel occurs together is minus factorial 8 by factorial 3 into factorial 2 into 5 equals to 1663200 minus 16800 equals to 1646470. Now the number of arrangement in which words begin with I and end with P is, let's fix the number of arrangement in which the words begin with I and end with P. Now we fix I at the left end and P at the right end. Left end and P at the right end. Then we are left with 10 letters. If we fix Y at the left end and P in the right end, then we left with 10 letters, in which 3 ends, 4 E's, and two Ds occur. Therefore, the total number of arrangement in which I begin with I and end in P is factorial 10 by factorial 3 into factorial 4 into factorial 5. Now circular permutation. Circular permutation of n different object. Circular permutation of n different objects is n minus 1 factorial. If we fix any one of these letters of this letter, then the remaining letter can be arranged in, if we fix the position of A, then the letter B, C, D arrange themselves in factorial 3 ways. Now the circular permutation are of clockwise and anti-clockwise. The circular permutation in which the clockwise and anti-clockwise arrangement give rise to the same permutation. If in circular permutation clockwise and anti-clockwise arrangement give rise to the same permutation, then the number of ways in which number of arrangement is n minus 1 factorial by 2. Let's take an example. Arranging some beads to form a necklace. Arranging some beads to form a necklace. In case of arranging beads, there is no distinction between clockwise and anti-clockwise arrangement. Therefore, the number of ways in which all beads can be arranged is n minus 1 factorial by 2. In how many ways can a party of 4 men and 4 women can be seated at a circular table so that no two women are adjacent. 4 men can be seated in a circular table. Can be seated in a circular table. Circular table. In factorial n minus 1 means 4 minus 1 factorial 3 equals to 6 always. Now, here is a condition: 4 women can be seated. No 2 women are adjacent. No 2 women are adjacent means 2 women cannot sit together. Therefore, the women can be seated in here, here, and here, and here. Women. Therefore, in these 4 vacant places, 4 women can be seated in factorial 4 ways, equals to 24 ways. Now these two events are dependent events because the arrangement of women is depend on the arrangement of men. Therefore, the total number of ways in which no 2 women are adjacent is 24 into 6 equals to 144 ways. Thank you. Please subscribe my channel and if possible then like.